All right. Welcome, folks. I decided I was going to record my lesson on quadratic functions. Um, so, quadratic functions, when you graph them, they always have this parabolic shape, kind of like a U. Um, your parent function for a quadratic function is f of x equals x squared. So it's always going to have some variable squared when you write the equation. The equations for quadratic functions show up three different ways. So the first way is the vertex form, f of x equals a times x minus h squared plus k. The second is standard form, f of x equals ax squared plus bx plus c. And then the third is factored form. So f of x equals a times your first factor times your second factor. So let's just kind of talk about some of the parameters in those equations. A is the vertical stretch. I'll talk more about that in a minute. In vertex form, h and k are the coordinates of the vertex. So note that in the equation, the h shows up opposite of the x coordinate of the vertex because it's minus h. But the y shows up the same as or the k value shows up the same as the y coordinate of the vertex. In standard form, c is your y-intercept, so that's where it crosses the y-axis. And then x equals h, that's your axis of symmetry. So parabolas are always symmetric. And so the axis of symmetry is just sort of like the line that goes down the middle of the parabola. Okay, let's talk about vertical stretch a little bit. If your a value is positive, your u is going to be right side up. If the a value is negative, the u will be upside down, and I'll show that a little bit on the next slide. If the a is greater than 1, the graph is going to be tall and skinny, and so that's compared to the parent function. It'll be taller and skinnier than the parent function. If a is less than 1, the graph is going to be short and wide. And again, that's compared to the parent function, so it'll be shorter and wider than the parent function. The domain for quadratic functions is really easy. It's always negative infinity to infinity. There's no number that you can't put into a quadratic equation. The range depends upon if it's right side up or upside down. If it's right side up, your range is going to be from k to infinity, where k is the y value of the vertex. And note that we use the bracket on here because that tells us that the function is allowed to equal k for an output, right? That's different than when we were doing exponential functions. They kind of had a similar sort of range, but there we use the parenthesis because in exponential functions they have an asymptote and they never actually hit the asymptote. That's not true for quadratic functions. Quadratic functions will hit the vertex. That's a point on the graph. So they're allowed to equal k, so that's why we use the bracket. And then if a is negative, you can kind of imagine this u being upside down. So now instead of k being the bottom of the range, it's actually the top of the range. So instead of going from k to infinity, it'll go from negative infinity to k. Okay. And then intervals of increasing and decreasing. So if the a value is positive, the graph will look kind of like this, like a U shape. And it'll have a vertex right here. And so your interval of increasing will be from h to infinity. Remember that h is the x-coordinate of the vertex. So it's going to be increasing from here going forward. So it'll be increasing from h to infinity. And then it'll be decreasing before h. So before h, the graph is going down all the way until we hit h. So it'll be decreasing from negative infinity to h. And then if the a value is negative, well, everything's just going to be opposite because the U-shape is going to be upside down. So it will be increasing from negative infinity all the way to h, and then after h, it's going to be decreasing. Okay, let's go through an example. So given the following equation, determine the vertex, axis of symmetry, and intercepts of the quadratic function. Create a table and graph the function. Finally, write the domain, range, and interval of increasing or decreasing. So here's our equation, 1/5 times x minus 2 squared plus 4. This is written in vertex form, so this will correspond to the first 3 questions on the assignment. Okay, let's start by identifying our vertex. We can get that from the -2 and the +4. So our vertex will be at 2, 4. And then this x value is our axis of symmetry. So the axis of symmetry is going to be x equals 2. The y-intercept, we can get that by taking our equation right here. And then what we're going to do is we're going to plug in 0 for x. So everywhere there's an x in the equation, I'm plugging in 0. 0 minus 2 is -2. -2 squared is 4. 4 times 1/5 is 0.8. 0.8 plus 4 is 4.8. So you can just type this into Desmos and it'll spit out 4.8. So we get 4.8 for the y-intercept. And then to get our x-intercept, that's going to be a very similar process, except now instead of plugging in 0 for x, we're plugging in 0 for y, or f of x. So this side of the equation is going to equal 0. We'll solve for x, so -4 minus 4. That'll give us -4 equals 1/5 times x minus 2 squared. Then we'll multiply both sides by 5 to get rid of the 1/5. That will give us -20 equals x minus 2 squared. At this point, we can say no solution because you can't square root -20, right? The square root of -20, when you plug that into Desmos, that's undefined. So this one has no x-intercepts. Okay, so now let's start putting our points into the table. First one I'm going to do is the vertex. That's going to be usually the point that I put in the table first. So that's at 2, 4. Our y-intercept is at 0, 4.8. So that'll be my next point. And then because parabolas have symmetry, that means that points that are equal distance from the vertex will have the same y value. So our vertex was at 2, 4. Our y-intercept is 2 points before the vertex. So if I pick a point that's 2 points after the vertex, it will also have a y value of 4.8. You can prove this is true by just putting 4 in for x in the equation, and it'll spit out 4.8. Okay, so now I'm going to take my 3 points and plot them. And then once they're plotted, I'm going to draw the parabola, right, which will look something like this. Okay, so now I have my graph. Now I just need to do my domain, range, and interval of increasing and decreasing. For domain, that will go from -infinity to infinity. That's true for all of these, so that's probably one of the easier parts of this. For the range, that's going to go from -4 to infinity. So I'm using my vertex for that. The vertex has a y value of 4. So my outputs for this function can be anything bigger than 4. So I'm going from 4 to infinity. My interval of increasing, so that's also using the vertex, but now I'm looking at the x-coordinate. It's increasing after the vertex because this is a right side up parabola. So it's going to be increasing from 2 to infinity. And then for my interval of decreasing, that'll go from -infinity to 2. Now just a reminder, I'm using the bracket with the range because the output is allowed to equal 4. I'm using the parenthesis with the interval of increasing and decreasing. And my reasoning for that is because the function itself isn't actually increasing or decreasing at the vertex. At the vertex, it's actually, you can think of it like not moving up or down. Okay, so that's our first example. I'm going to go through two more. The next example is probably the most tricky, and that's because the equation's written in standard form. Okay, so let's start by using the equation to find the vertex. And so I have my equation right here, 3x squared minus 4x minus 4. And then that equation is written in standard form, which is f of x equals ax squared plus bx plus c. So each one of these coefficients is going to correspond to a, b, and c. A is 3, b is negative 4, and c is negative 4. Okay, you can calculate the x coordinate of your vertex, or the h value, using this formula, negative b over 2a. B is negative 4, so we're going to say negative negative 4 on top. Right, the first negative comes from this negative. The second negative comes from the fact that b is negative 4. The a value is 3, so I'm plugging in 3 on the bottom of this, formula. Negative negative 4 is 4, and 2 times 3 is 6, so this is going to become 4 over 6, which reduces to 2/3. So my a value, my h value is 2/3. Now if I want to get my k value, I have to plug in 2/3 into this function. So I'm going to put in 2/3 for x. So I'm going to say 3 times 2/3 squared minus 4 times 2/3 minus 4. And if I calculate that using Desmos, I'm going to get negative 16 over 3. So what that tells me is that my vertex is at 2/3, comma, negative 16 over 3. That's what I'm writing in. And then I have also solved for my axis of symmetry at this point, because that's just the h value, or the x coordinate of the vertex. So we're going to say x equals 2/3. For my y-intercept, I'm going to take this equation, and I'm going to plug in 0 for x. So I'm just plugging in 0. I end up with negative 4. So my point is going to be 0, comma, negative 4. Note that this is the same as the c value of the equation written in standard form. So I could have just looked at my equation and said, oh, the c value is negative 4, so then my y-intercept is negative 4. You can do it either way. I just showed plugging in 0 because I want you to know that that's always one way that you can get the y-intercept. And then to get the x-intercepts, we're going to take our function, and then we're going to set it equal to 0. So we're going to say f of x is 0. So I'm going to show how to solve this two different ways. The first way I'm going to show is by factoring. So we're going to create a box. And in our box, we're taking our first term, 3x squared, and we're going to put it here. Taking our second term, minus 4, and we're going to put it here. And then we need to take minus 4 and split that up in the remaining two boxes. So I'm going to show that using the x method. So on top of my x, I'm just going to take my a term times my c term. So 3 times negative 4. That's negative 12. On the bottom of my x, I'm putting in my b term, which is negative 4. So I need to find two numbers that will multiply to negative 12, but add to negative 4. So my process for doing this is going to be to find all the numbers that multiply to 12 first. So what numbers multiply to 12? Well, I could do 1 and 12, I could do 2 and 6, or I could do 3 and 4. I actually want it to multiply to negative 12, though, so one of those has to be negative. And then the numbers, when you add them together, they'll have to add to -4. So since one number's negative and one number's positive, that means that the numbers will actually have to be 4 apart. So the numbers that I want are actually -6 and +2. Because -6 times 2 is -12, and -6 plus 2 is -4. So then those are going to show up in the box, but I include an x with them because remember, these two terms are going to add up to equal my middle term, -4x. And now I can start to factor this. So if I think about 2 and -4, and I think about which numbers what's the biggest number that will divide into both of those, it actually ends up being 2. 2 divides into 2, 2 divides into -4. Now I'll do the same thing with 3x squared and -6x. That's going to be, with 3 and 6, 3 divides in there, and then since they both have an x, I'm also going to pull out an x. With 3 and 2x, there's no number that divides into 3 and 2, so I'm actually just going to pull out an x or a 1x. And then with -6 and -4, 2 will divide into both of those numbers. Because the first term is negative, I'm also going to pull out a negative. So it's going to be -2. Okay, so now I have my two factors, x minus 2 and 3x plus 2. And so I will rewrite my equation as 0 equals 3x plus 2 times x minus 2. And then what I'm going to do is I'm going to take each of these factors and set them equal to 0. So I'm going to say 0 equals 3x plus 2 and 0 equals x minus 2. And then I'm just going to solve each of these for x. So in my first equation, I'll subtract 2 from both sides. That'll get me -2 equals 3x. Then I'll divide both sides by 3 and get -2/3 equals x. And then with my second equation, I'm just going to add 2 to both sides and get 2 equals x. Okay, and so then those are my x-intercepts at -2/3, 0, and 2, 0. So that's one way I can solve for my x-intercepts. Those of you that took Algebra 2 with trig, you also probably learned the quadratic formula. So that's what I'm going to do next, is show how to solve for those x-intercepts using the quadratic formula. Okay. So I'm going to show how to solve this. I'm going to again remind you that this is standard form. So in standard form, 3 corresponds to A, -4 corresponds to B, and -4 corresponds to C for this equation. The quadratic formula looks like this. Your x-intercept equals -b plus or minus the square root of b squared minus 4ac all over 2a. I would make sure that you write down this formula if you're planning on solving for x-intercepts this way and not factoring. This would be a really good thing to put on your note card for the test. So we're just plugging in for wherever there's a b in here, we're plugging in -4. Wherever there's an a in here, we're plugging in 3. And wherever there's a c, we're plugging in -4. Right? -4. Okay, now let's simplify this a little bit. -4, that's 4. -4 squared is 16. -4 times 3 times -4 is 48. And then 2 times 3 is 6. Now we can add 16 and 48 together. That will give us 64. And the square root of 64 is 8. Okay, now what we're going to do, because this is plus or minus, is we're actually going to split this into two problems. So the first problem is going to be x equals 4 plus 8 over 6. 4 plus 8 is 12. 12 divided by 6 is 2. Our second problem is going to be 4 minus 8. So I have it written as 4 minus 8 over 6. 4 minus 8 is negative 4. Negative 4 divided by 6 is negative 2/3. Okay, so we get the same two answers for our x-intercepts, 2 and negative 2/3. And so we'll write those as ordered pairs. Negative 2/3, 0, and 2, 0. Okay, our next problem is going to be to fill in the table with the points that we found. So I'm going to use the vertex, the y-intercept, and this x-intercept. So my vertex is 2/3 and negative 16/3. My y-intercept is 0, negative 4. And I'm going to use this x-intercept in the table, 2, 0. Next, I'm going to plot the points. I actually plotted both x-intercepts along with the y-intercept and the vertex. And then I will make a parabola go through those points. Domain, easiest part of the problem. That just goes from negative infinity to infinity. Range, again, we get that from the k value. So the range is going to go from negative 16 over 3, that's the bottom of my vertex, all the way up to infinity. Because my parabola is right side up, so we're going to include all the numbers that are bigger than the k value. Interval of increasing, that's also going to use the vertex, but that's going to go from 2/3 to infinity. So it's just going to be all the numbers that are bigger than 2/3. And then our interval of decreasing, well, it's going to be decreasing before the vertex. So that'll go from negative infinity to 2/3. Okay. So that's the end of example 2. We have one more example that we're going to go through, example 3. With example 3, I have the equation written in factored form. I think factored form and vertex form are a lot easier than standard form. With factored form, though, the factors make it really easy to solve for the x-intercepts. So I'm actually going to start with the x-intercepts on this one. We're going to start by solving the x-intercepts by setting the equation equal to 0. This was the first way that I showed how to solve for the x-intercepts when the equation was written in standard form. I think that this is the easier, that will be the easiest way to solve for the x-intercepts for that one. Is we're just going to take each of our factors, so x plus 2 and x plus 4, and set them equal to 0. So my first x-intercept is going to be, when I subtract 2 from each side, I get negative 2 equals x. My second x-intercept is going to come from subtracting 4 from each side of this one, and we'll get negative 4 equals x. So my x-intercepts will be negative 2, 0, and negative 4, 0. To get my vertex, well, it just so happens that the vertex is always in between your x-intercepts. So my vertex is going to be the point that's in between negative 2 and negative 4. So in between negative 2 and negative 4, you can probably spot that that's going to be negative 3. You can also, if you can't see where the exact middle is, you can just add your two x-intercepts together and then divide by 2. So negative 2 plus negative 4 is negative 6, divided by 2 is negative 3. Okay, so your vertex is going to be at negative 3. How do we find where, that's the h value. How do we find where the k value is? Well, we're going to take our equation, and we're just going to plug in negative 3 for x. We're just going to plug in the h value, or the x coordinate of the vertex. So wherever there's an x, I'm putting in negative 3. Negative 3 plus 2, that's negative 1. Negative 3 plus 4 is positive 1. So I'm getting negative 2 times negative 1 times 1, which is really just going to be 2. So my vertex is at negative 3, 2. And that's going to go in for x and y. My x-coordinate of my vertex is my axis of symmetry. And then the last thing I need to solve for is the y-intercept, so I'm going to put in 0 for x. So I have my equation. I'm going to put in 0 for x. F of 0 equals negative 2 times 0 plus 2 times 0 plus 4. So f of 0 is going to equal negative 2 times 2 times 4. F of 0 is going to equal negative 16. And so then we can add that as our y-intercept. We can now put points in the table. I'm going to use the vertex and the x-intercepts since the y-intercept isn't going to be in our window. So my vertex is going to be at negative 3, 2. I have one x-intercept at negative 2, 0. I have another x-intercept at negative 4, 0. If I plot them, it'll look like this. Right? Negative 2, 0, negative 3, 2, negative 4, 0. Oh, I did that backwards. Negative 4, 0, negative 3, 2, negative 2, 0. And then we'll put a parabola through that. So it'll look something like this. Okay, and so then my domain, easiest part about this, negative infinity to infinity. My range for this one, note that this range is going to look a little bit different than the other two problems. That's because this parabola is upside down. So my range actually goes from negative 2 to infinity. I didn't highlight the vertex, but my vertex is right here. So my range is going to be all the values that are below the vertex. My interval of increasing, that's going to go from negative infinity to negative 3. So it's increasing all the way until we hit this point right here. And then afterwards, we're decreasing. So from my vertex on, it's decreasing. And that's it for my third example. So hopefully this will help some of you understand how to do these problems. Note that example 1 is going to correspond to problems 1 through 3 on the assignment. Example 2 will correspond to problems 4 through 6. And example 3 will correspond to problems 7 through 8. Let me know if you have any questions.